Hey, my name is Jeremy Snyder, and I'm here to talk about effective API security. So thank you so much for joining me today at API Days Paris, December of 2023. And when I talk about effective API security, really what we want to focus on today is how we build bridges between different teams that are all part of the area of responsibility for API security. So let's dive in. We've got a lot to get through in these 25 minutes. And we're going to talk about the current state of API security, some breach case studies in history, and actually, we've got an even more dangerous situation ahead of us with regards to API security. So, I want to touch on some of what we're looking at and what we're hearing from our customers and from analysts in the market. And then we want to get into some effective API security strategies and answer that question that I posed at the beginning, which is how do we bridge that gap and bring everyone onto the same page when it comes to securing our APIs? And we move from just development into kind of development plus security plus operations, all in an integrated information loop. And definitely want to have some time for questions. Unfortunately, for this pre-recorded session, we're not going to be able to take them. But I would encourage anybody who's watching this after the event or on the live stream, please do reach out if you have any questions. How can you do that? Actually, my email address is at the bottom of this page. That's a QR code to connect with me. We'll have a few other QR codes during this presentation. Hit pause anytime if you want to scan them, or obviously just reach out if you need a copy of the slides afterwards to do so. The only thing I'm going to say about myself is just know that I've been working in the technology space for about 25 years now. That's been a combination of IT, cybersecurity, plus cloud, plus, actually bringing it all together as we're doing here at FireTail, where we are a cybersecurity company built on APIs in the cloud. So let's talk about API breaches. For the past about 2 years, just shy of 2 years now, the team at FireTail, we've been putting together a list of all of the API breaches that we can find. And not only putting together that list, but also diving deep onto understanding and analyzing why these breaches have happened, how they've happened. And earlier this year, I gave a talk where I kind of took issue with a data point that Gartner had put out about 5 years ago. About 5 years ago, Gartner said by 2022, which was actually last year, yes, but by 2022, APIs would become the number one attack vector. And I said, you know what? It didn't happen. Don't get me wrong, API breaches are up quite a lot, as we're going to talk about in a minute, but I don't think they became the number one attack vector. Gartner saw my talk, and someone from Gartner reached out and actually provided us with data to solidify and underline their point. And it's been really interesting because what we've seen is that we know APIs represent 90% of the attack surface of modern web apps, and in fact, modern mobile apps, modern IoT apps, because we know that actually those are mostly kind of sensors or they're thin clients at the front end talking to the back end over APIs. So we know that APIs are this intentionally represented and exposed thing, but are they really the number one attack surface? And that is specifically what I took issue with. So the data that Gartner came back with was really interesting. So they combined some of their data with some IBM data. And what they actually showed is that APIs are involved in more than 90% of all the attacks that are happening. So really to claim that they are the number one attack surface, it's a valid claim. So they are becoming the low-hanging fruit, and they're very interesting because APIs do a couple of things differently from other attack surfaces that we look at. APIs sit in front of data. Yes, lots of things sit in front of data. Firewalls sit in front of data. Network security groups sit in front of data. But APIs also sit in front of applications. And that combination of sitting in front of apps and data is, I think, what makes APIs particularly attractive and particularly useful to attackers. As a result of that, in 2023, we've seen API attacks up over 700%. And that has been just a staggering number to watch. And by the way, that even excludes a couple of particular events that we're going to talk about. Have a look at our API data breach tracker. The URL is there at the bottom of your screen. Digging in, we started our analysis and we did our initial report on this in May of this year. We gathered the data for quite a bit longer, but we started analyzing and produced an initial report around the state of API security in May of this year. And just since May, we've had to update our stats quite a bit. So at that time, we had seen about 500 million, well, just shy of 600 million records exposed. Now we are getting close to 1.5 billion records exposed or at risk of breach. We've also seen that the number of records per breach event has risen since that initial analysis. And it's really interesting when you look at both the size of an API data breach, on average, 22 million records, versus the size of a non-API breach, 25,000 records. Why is it, more than two orders of magnitude more, or just about two orders of magnitude more? It's because API breaches are systemic or systematic. They affect an entire app or an entire data set sitting behind the API. So those are some of the really interesting data points that came out of our research. And when we also started to analyze how these breaches happen, we found that the top of attack vectors can be broken down into a few categories. Number one and number two, not too surprisingly, are authentication and authorization. And these come up time and again. And just to clarify, when we say authentication and authorization, no, we're not talking about the same thing. The two things are different. Authentication means establishing my identity as Jeremy. Authorization means checking what are the things that Jeremy is allowed to do with this API. As an example, I might be able to view my own profile. I might be able to edit my own profile. I might be able to view somebody else's profile, but I shouldn't be able to edit somebody else's profile. So permissions and identity are not the same thing, but we actually see that problem pretty much as a standard pattern across a number of API breach events. When we look into some of the other categories, we see some common problems around configuration. So that would be an internal API that accidentally gets exposed publicly. We're going to talk about a case study of one of those in a second. That would be something like an API that is returning too much data because the API is not configured to only respond with the data requested. That might also be classified as governance. It kind of depends how you look at it. We put it under this bucket, but you also do see injection. We do see APIs that are not sanitizing inputs, APIs where passing a bad query parameter or a bad request payload can actually trigger unexpected behavior. And in fact, the number one breach from 2023, which was Progress Software's Move It file transfer software being breached by again and again across more than 2,000 organizations, it was an injection payload encoded and put into a file upload resume API that introduced the ransomware into these organizations. So that's where injection actually may need to get reassessed in our report going next year and kind of reflectively grown quite a bit. So let's take a case study example about one data breach event and what we can learn from it. This one is just over a year old at this point. This is a company called Optus. It's a telecom provider in Australia. It happens to be the second largest mobile carrier network in the country. Roughly 40% of the population subscribes to Optus, Telstra being number one in the market. What happened in this case? This is a multi-vector breach where a simple network configuration change made what was meant to be an internal API public. Now, that API got discovered. And in fact, in our own labs, we stand up a number of APIs where we test out our own software, we test certain attacks, breaches, et cetera, breach techniques against those APIs, et cetera. And when we do that, one of the first things we noticed is that any API we put out into the world starts getting probed within about 5 minutes. And now these are APIs that are just sitting on a random network port on, well, I shouldn't say random, but on a standard HTTP network port on any random IP address is what I meant. And no DNS names assigned, so nobody's enumerating our domain. It's just that we put something live on the internet and it gets discovered and it gets probed within about 5 minutes. When it gets discovered, what we see is follow-up enumeration attempts. And what that's looking to do is to discover common API endpoints, something like a /admin, /user, /create, whatever. And we see follow-up activity probing for common software packages. So we're looking for things like, oh, is this IP address, is there a WordPress instance running? So we see things like /wp-admin. We also see probing for things like Progress Software's Move It file transfer software. So any kind of enumeration follow-up requests, we're seeing those pretty consistently within our lab environments. And just be aware that's happening to anything that you put live on the internet. Coming back to this Optus breach, so we had really poor authentication with an API that was meant to be internal, now made public. And then secondarily to that, we also had incremental account IDs. So if my user ID is 1, the next user is 2, 3, and so on. So what do we have? We have poor network change management within the organization that made this public. We have bad data handling on the account IDs, and we have easy access with no authentication. Just a comment from the attacker in somewhat broken English, no authenticate needed, all open. Great. Some other recent high profile events from this year, some of these are disclosures. Obviously, the one I've mentioned already from the MoveIt file transfer software, we've talked about a bit, but three other disclosures I would point you at to look at. More than 2 billion records at risk. We didn't include those into our kind of 1.5 records breach number because those were responsible disclosures, not breaches. We tried to be a little bit careful about keeping those two things separated. So it is a huge ramp up in API security vulnerabilities, breaches, risks, et cetera, in 2023. Other analysis, I already mentioned that kind of multiple things went wrong. So that second bullet point about multi-vector, that has been common across pretty much all of the breaches that we've seen, not only this year, but in all of the years going back. You can almost always find two or more things that went wrong in those. APIs are everywhere, so this is not industry or geography specific. That said, some industries are a little bit overly represented. So we've seen manufacturing, the automotive. Have a look at that connected car stuff. You can find some research about that on our website as well. This is kind of this automotive space is what I would call a modern digital supply chain around functionality and data that you're fetching from third-party sources in order to empower and enable a connected car. That same kind of supply chain effect, by the way, is present in everything from mobile apps for food delivery and ride sharing to almost every mobile app. Most mobile apps are not 100% homegrown technology where every piece of the application functionality is built by the app developer. Almost all of them involve calling some third party service for either fetching data or processing a function or whatever. Software, unsurprisingly, was pretty heavy in the list. Who writes APIs? Software companies write APIs. And then last but not least, I'll just point out that hospitality was also very heavily represented in the list. If you think about platforms like Booking.com or Expedia, Orbitz, it's Kayak, et cetera, you're very often booking tickets, accommodation, rental cars, et cetera, through a provider who doesn't actually provide the service, but just connects you to the best price. And then you kind of get a reservation through that portal. All of those reservations are actually transacted over APIs. Two more things from our analysis. One is we actually gathered the top 6 problems, and we're going to talk about how these inform some of the strategies for bridging the gap. Lack of inventory, understanding what a perimeter is for an API is actually quite complex. And then tracing, security configurations, change management, and the gap between developers and security. So a couple of those points, especially the gap and the change management and the end-to-end tracing, really point to the need for developers who write APIs to connect with security teams who are accountable for these APIs in production. So how do we think about solving that problem? Well, we've got the OWASP API top 10, but a question that we come up against quite often is that a standard for API security, or is this just telling us what our risks are in our APIs? Also, are they one size fits all? We've heard from a number of frustrated organizations that have tried to implement API security and then found that it fails because it's built on a single algorithm that is designed around, let's say, network traffic analysis that is one size fits all around the entire technology footprint. But production and non-production don't have the same standards. Second, around the OWASP API top 10, we've seen a little bit of head scratching around why did it go 4-year between updates? And then with that, how come there wasn't much change between the two versions? And then the second is, if you look at, let's say, one item from that list, broken object level authorization, BOLA, number one on the list from 2019 and 2023, nobody tells you how to avoid BOLA risk or how to remediate it or how to kind of manage it. There's no set of controls around it. So again, back to that question, is it a risk model, a threat model, or is it actually a standard? And most organizations, when they start this, they're really looking for answers for specific things that they are doing wrong that they can fix in their APIs. By the way, We're about to enter an era where API security becomes much more prominent and becomes a much bigger challenge for organization. Why is that the case? Well, it's late 2023. As anybody who's been paying attention this year knows, we are entering the era of mass AI utilization across the enterprise. And in fact, OpenAI just recently announced a whole set of API capabilities. This is going to bring huge attention to API utilization, but it also brings API risk. On the attacker side, we already know that things are getting probed within a matter of minutes. We already know that attackers have been using automation for years, but now it becomes cheaper and easier to develop new potential malware that can take advantage of APIs or that can breach API business logic and really kind of look for some of those authorization and authentication vulnerabilities or potentially query data sets deeper and try to scrape them, et cetera. And then there's a set of unknown unknowns. Now, OpenAPI and its ChatGPT product, they do have a set of guardrails around, not allowing malware authors to abuse their capabilities. But we also know of kind of dark web programs like Fraud GPT, Worm GPT that don't have those controls in place. So that's what's coming on the attacker side. On the defender side, API utilization is about to shoot up probably 100x over the next couple of years, if I had to guess. And one of the big reasons why is that most organizations aren't at the size and scale and sophistication where they can run their own LLMs, large language models. What that means is that they're going to be sending a lot of their core corporate intellectual property into these models in order to supplement them because that gets the best results for the organization. It's when you use a potentially general purpose or an industry trained large language model coupled with your proprietary data that you're going to get the best results for your organization. And so we're going to see so much proprietary data crossing API wires. And so that this is where I think there's a lot of potential risk, but also a lot of opportunity to help organizations do better with their strategies. So let's talk about effective API security and particularly around building bridges between developers and security teams. I started by asking one of the AI tools, I think Midjourney in this case, to get us an image that represents security teams and developers meeting on a bridge. This was the first one, just two random people walking on a bridge. Don't know that that says anything about developers and security. The second one got a little bit better, where you can kind of see some sort of technology views, but really you're looking more at like battlefield maps. So I guess the bridge here is kind of the control bridge, like on the Star Trek Enterprise. Any event, last but not least was this one, which I thought was maybe the best. It's kind of a San Francisco-ish, so it kind of hints at Silicon Valley. You have two big groups kind of separate from each other, meeting on a bridge, and you've got those two rebels in the middle that are talking to each other. So that's the one startup that is actually having developers talk to security teams to get it right. Well, how do we do this? And what are some of the key learnings for effective API security to make this happen? Well, we know that traditional security doesn't really work. We've taken that OWASP API top 10, by the way, and we've mapped it onto this kind of representation of API traffic. And when we kind of look down the list of these top 10 risks, what you'll notice as that screen populated is that almost all of the risks sit outside the gateway and proxy, which is where the security team tends to be most active, and they sit at the server level. You can argue about authentication there because that can be delegated. You can also argue with me, by the way, whether authorization can be delegated. And in fact, if you do want to have that conversation, please come talk to me. I want to introduce you to our VP of product who's working on some really interesting stuff there. But what you see is that, 70, 80% of the risks live inside the server, inside the application logic. And so when we talk about abusing business logic, this is really what I'm hitting at. And that's, again, where our data analysis kind of shows us the risk lies. Also kind of color coded this to try to understand, well, who owns these things? And I apologize if this display on the screen is not super clear, but what you'll see is that basically 7 out of 10 are owned by the developers. 2 are kind of shared responsibility, and only 1 arguably is purely the domain of the security team. And that is kind of debatable. So we're thinking about the accountability, and that shows that we've got split accountability. So how do we bring that together? The first component is equipping both sides with ongoing visibility. How do we do that? We do that through ongoing Discovery. Discovery is a very interesting topic for APIs. Why? Because APIs are code, they're pieces of software, they sit in front of an application, but they also sit on a network. And by the way, most API development is done on cloud platforms. So when we think about discovery, one of the things that we've tried to do when working with our customers is figure out ways to get them ongoing API discovery from code to cloud and across the network. That builds visibility, which allows you to observe the APIs. And through that, you can actually start to see some of your risks. You can see the risks through the configuration and the design of the APIs and into the utilization of the APIs. And then when it comes to understanding those risks and figuring out ways to mitigate them, you can compare to a policy lens and then look at enforcement and audit. And so we've seen this kind of adoption path that starts with those discovery and inventory steps that I mentioned earlier. That allows us to observe. And then when we think about kind of eliminating flaws or mitigating flaws, we can bring in that policy engine. The policy engine allows us to build a feedback loop. So what does this mean in practice? What this means is that you want to find your APIs, and then you want to pave a clear path for developers while you're doing that so you can build this kind of continuous feedback loop. So let's go into one example of how we do that. So we build API discovery across cloud platforms and through code. And with that, we start to find problems. And those problems are kind of categorized into categories aligned to the risk model and looking at specific issues. So let's take the example of using numeric IDs, which is part of what we saw in that Optus example, present in many of the other breach events that we've seen, where numeric IDs allowed for very, very thorough data scraping, which, by the way, increases the size of the breach sets again and again and again. And so what we're looking for here is we've got a problem of numeric IDs. Where is it? What is the problem? How do we fix it? And one thing that we found is that if you can not only highlight the problem, but you can get down to the level of where that problem lies, you might see like line numbers and character numbers there. You can actually give the developer example scenarios with code to kind of find the problem and then updated code recommendations for how to fix it. And that's part of empowering that. So there we've got kind of a miniature closed loop between kind of the design of the API, the publishing of the API, capturing problems there, feeding that back. And when we think about another set of heavy risks around those, we're looking at authentication and authorization and data exposure. We need to look at the application layer because when we look at the telemetry data coming off of cloud platforms, in this case, we're just looking at AWS, we can see that we only see the necessary data elements off of application layer logging. So that tells us that the next thing we need to do is instrument our APIs with telemetry data that gets us up to the level of visibility that we need it to be at. So from this standpoint, we're going past this discovery and inventory step that provides the visibility to both teams. We've gotten into the policy that created the policy assessment that creates the feedback loop to eliminate design flaws. And now we're getting into the attack prevention at that top layer. One last very interesting point is that when you get into that attack prevention and you get into that deep layer, you actually automatically build a centralized audit trail of your APIs, which is super beneficial from a forensics and incident response standpoint. Awesome. Well, those are some of the tips that I wanted to share today around bridging the gap and then looking at the effective API strategies, what we need to look at. Definitely would have time for questions. Would love to talk to any of you. Please feel free to reach out. If your organization is looking for an API security solution, we are offering 60% off the enterprise plan through the end of January 2024. Just scan that link and reach out to us. Or if your organization is just kind of curious at this point, how good or bad are you at API security? You could scan that link on the right and win a free API security assessment. This is something that we do for customers, normally a paid offering, but happy to do that for people who are here today. With that, I will say thank you very much to all of you for watching and to the entire API Days team for putting together API Days Paris 2023. I hope this has been useful for you. If you have any questions, please don't hesitate to reach out to me, Jeremy at FireTail.io, or anybody on the FireTail team. Thanks so much.